Nabia, we can start.
Okay, so thanks everyone for joining us. Welcome to Weaviate's workshop. So I would encourage everyone to open their videos, and the session is more interactive. Couple of guidelines before Scott takes over. So just make sure, because this session is interactive, so you will be getting a chance to speak and ask questions to Scott anytime. Just make sure, be mindful when you're speaking, raise your hand so Scott can of course give you a chance. If there are any questions, you can also drop them down in chat. Stay present, stay focused, try to keep your camera on. It will make the workshop more interactive. Moreover, the session recording plus the resources will also be shared afterwards. Just one last thing, make sure that you're muted if you're not speaking, so just to avoid background noise. And we're very excited to have you here, and we look forward to a very interactive session. So let's begin. Scott, you can take over.
Awesome. Thank you so much. Okay. Right, I'm just troubleshooting something really quickly. And I think we're ready to go. Yes. Okay. Okay, you should be able to see my screen, yeah?
Yes.
Excellent.
Now, excuse me, can you hear me?
Yes.
Yeah. Before we start, can we do we plan to record this one?
Yeah. This will be recorded and shared with you.
Oh, okay. Thank you.
After the session. No worries.
Great. Well, thank you, everybody. Oh, yes, go ahead.
I'm creating that Weaver cluster account. Sorry, I couldn't able to create. I was busy. I was also maintaining my work. I'm creating it. So is that mandatory? Priorly, we have to create that account, the cluster account?
Yes, if you would like to code along during the workshop portion, you'll need to have a cluster and those API keys. But we will have a little bit of time before we start coding where we'll do a couple of breakout rooms where Duda and I will get things set up so that we're good to go.
Thank you.
Yeah, you're welcome. Okay, well, thank you all for coming. I really appreciate your attendance. I'm really excited to talk to you all a little bit today about setting up a vector database and using agents to query that database, as well as just showing you some of the cool stuff that you can do very, very simply with agents. It's kind of misunderstood around agents because they're kind of a new thing, right? Everybody's talking about them. They're super hyped. They seem really complex, but I think by the end of the workshop, you'll feel comfortable enough to is Scott Askinosi, and I work as the lead technical trainer at Weaviate, and Weaviate is a vector database. I have with me another friend of mine from Weaviate. His name is Duda, and he's really awesome. He's going to a lot of people don't really and virtually everything we do these days involves search. And search can come in many different all of these are handled through databases that store information. And he who builds a better mousetrap, the world will be a path to their door. The same thing is true with search. Everybody uses search, and the better your search is, the better the user experience, and the more pertinent information you're going to be able to pass on to the end user. So with traditional search that's been around since the early days of the internet, we see that there are some problems, right? No search is totally perfect. And that's because there are things that will interfere with our search, make it a little less precise. And one of these issues you've probably seen firsthand. So here is an example search query. Why do airplanes fly? And you see our return is why you should fly with expensive airplanes. This is for a few different reasons. The first is traditional search works with keywords, right? Like a lot of search that we use even on our own personal computers. And if you look here, we do have matches for these keywords. We got fly, airplanes, why do. But this isn't exactly what we're looking for. The other half of this is a lot of search these days is focused on selling this stuff, right? So even if you're searching for something that has nothing to do with buying something, you're probably going to get an ad or two. But it isn't always exactly what we want. Hence the meme. You ask how airplanes fly, you need to fly with expensive airplanes. The question is, can we do better? And the answer is yes, we absolutely can. And this is where semantic search comes in. And we're going to find out that semantic search is why we use vector databases. So in the next few minutes, we'll talk about what a vector database is, how it works, and why this can help us with search. Because semantic search is technically at the heart of what we want with search. We don't want something to just match our keywords. We want our search to understand what we mean. We want it to be able to dig into the context of what we're asking it and say, okay, these are the keywords, but this is probably what they mean by this question. And semantic search can do that. It can actually read the sentence and understand it contextually for the semantic meaning and return us more accurate responses to our queries. Like this, for instance, when we ask, why do airplanes fly? We don't want to know about it flying on an expensive airliner. We want to know the aerodynamics of how a plane flies. And semantic search allows us to do that. Traditional search, not always what we want. Semantic search, generally a lot better. So how does this work? How do computers understand what we mean, not just what we say? Well, that's what we're going to talk about. And we're not going to think about it like a 5-year-old. We're actually going to learn it more like a 10-year-old, because we want to go a little bit deeper and understand fundamentally, like what's happening in a vector database and how does this give us better search results? And the answer is it all comes down to machine learning models, which a few years ago started something that people talked as much about, machine learning models. It was a little bit niche. Generally, the ML engineers talked about machine learning models or data scientists. But with the introduction of large language models, machine learning models are everywhere, right? We use them every single day. And they're becoming a lot more popular. So it's a good thing to understand the different types of machine learning models out there, as well as how they operate and what they can do for you. And vector databases, they don't behave, or they're not structured the same way that a traditional relational database is. Like, think like an Excel spreadsheet or a SQL database, or we have rows and columns of information that are related to each other, hence the name relational databases. Vector databases work a little bit differently. They actually can take words or images or sound or video and turn them into numbers, aka vectors. Because LLMs and other machine learning models, they don't understand language. They can't read language as it's written. They don't really understand images or video or sound. You need to convert that into numbers so that the machine learning model can then use those numbers to make sense of it, which is essentially how LLMs work under the hood, right? They take the words you send and they turn it into tokens. And they actually put that into a vector database. It operates a little bit differently than the vector database we're talking about today, but LLMs under the hood are using vector databases to understand semantically what you're trying to say so that it can predict the best response to what you're saying. So with vector databases, what we do is we take any type of data, whether it be text, whether it be video, audio, image, and we're going to turn that into a vector. And a vector is essentially just a list of numbers, which will be shown here. So we can take the information that we want to return to a user and turn it into a list of numbers. So here we have our first return, our first thing that we found on the internet, fly with expensive modern airplanes. We take that and we turn that into a number and we put it in our database, because our database is going to store all the possible information that we could possibly want to return to a user based on a query. So if we're talking about the internet, that's definitely going to be in there. We can also take our aerodynamics of how planes fly and we can turn that into a number as well. But great. So we take all of our data and we turn it into numbers. Like, who cares? What does that do for us? Well, the way that vector databases operate is really ingenious, because they can take those numbers and make sense of that numeric information in a way that's very similar to the way that we think about the world. So what does that mean? Vector databases, or machine learning, the machine learning models that take this information and turn it into numbers, these are called embedding models. Another name for a vector is embedding. So these models take the information and they turn it into these lists of numbers. And these lists of numbers can have a varying amount of numbers within them. And we call that dimensionality. So if this list only had 3 numbers in it, we would say it's 3-dimensional. If it had 500, it has 500 dimensions. If it has 1,000, it has 1,000 dimensions. And the dimensionality of vectors can really vary. You can have anywhere from 250 dimensions to 5,000 dimensions when you're working with different embedding models. But conceptually, the way that this works is, we're used to thinking in the world in 3 dimensions, right? We have length, width, and height. You could make the argument that we can actually experience the world in 4 dimensions because we have time. So in 3 dimensions, we can say that 2 objects are close or far away from each other in physical space, right? So my hand is closer to the computer than it is to the ceiling. 4 dimensions, you could say we are closer to the fall of Rome than we are the dinosaurs, because we're closer in time. Machine learning models use these embeddings, these vectors, to place objects, whether it be text, video, audio, images, into multidimensional space. And what that does is it allows objects that are similar to each other to cluster together in this multidimensional space. We're going to use this 3-dimensional image here to conceptualize this, because as humans, it's hard for us to think beyond 4 dimensions. We can't actually conceptualize that because we're only able to understand 4 dimensions. But computers are able to see 10, 20, 1,000, 5,000 different dimensions simultaneously. But to keep this simple, let's look at this 3-dimensional vector space we've created here. Similar objects are going to cluster together. So we have the word wolf and the word dog. These are both 4-legged mammals. So they're going to cluster together. They're also members of the genus known as Canis. So they're very similar in terms of taxonomy in the animal kingdom. So they're going to be very close together. And we know as humans, wolves and dogs are very similar. Cats are also 4-legged mammals. So they're going to cluster near dog and wolf, which are other 4-legged mammals. But cat is not as close to dog as wolf is, because dogs and wolves are a lot more closely related. If we look at the other side of this vector space, we see that the word banana is very close to the image of a banana, because semantically, those 2 things are very similar. They both talk about the same thing, a banana. Whereas we have the word apple and apple are very close together, but they're kind of far away from the image of Macintosh logo, the apple, Apple's logo, the apple. So hopefully this helps kind of conceptualize how a vector database works. We take all of these objects and we put them into our database, and objects that are similar are going to cluster together. And this is a really important aspect of vector databases, because this is how semantic search works. Under the hood, this is how RAG systems operate, or how LLMs work, is that they're able to leverage this multidimensional space to understand semantically what objects are similar to each other. Okay, really quickly, I see that there's a question in the chat. Before embedding the real world data, how do we decide the dimensions? Which one is better? That's a really good question. And we won't get into this a lot today because that's kind of pretty deep into embedding models, but it really depends. So to give you the short answer, the more dimensionality you have, the more detail you can store in that embedding, in that vector. However, once you get beyond, again, depending on your use case, 1,000 or a couple thousand vectors, or I'm sorry, dimensions, the amount of information that you're storing in there is so minute, it's probably, the juice probably isn't worth the squeeze for general purposes. So most embedding models operate between 250 and about 1,200 dimensions. So the model that we're going to be using today uses 254 dimensions, and that's, you're going to see that's plenty of dimensionality for us to be able to separate concepts that we're working with. Like for instance, banana and apple. You don't need 5,000 dimensions to be able to separate between those. Okay, hope that answered your question, but if you have any more, feel free to follow up in the chat. Okay, so let's look at this three-dimensional space. Let's use this in a real-world application. Ooh, good question. Could more dimensions after a certain point cause overfitting with model training? I don't know. Let me think about that. I'll come back to that in a second. I'm going to need a noodle on that one for a second. My gut says I don't think so, because the more dimensionality you have, it's going to just allow you to store more information about a particular object. But let me noodle on that, make sure that I'm not giving you bad information. Okay, so we have this vector space. We've taken all of these objects, like we talked about before, the part about flying on expensive airplanes, and then the text about aerodynamics. So we have all of these different concepts, all of this different chunks of information of text that we put into our vector database. So great, we now have this vector database full of information. How do we get the right information out? Well, the answer is actually really simple. So we used this machine learning model to take our information and turn it into these vectors. Well, now we're going to take our query and we're going to pass it through the exact same machine learning model. And what it's going to do is it's going to take our query and it's going to turn that into a vector. And we're going to drop that into our database. And it's going to be right here at the center of this circle. Now, I told you before, objects that have similarity are going to cluster together. So what this means is we can look at the objects that are closest to our query vector, and we can say with a pretty high degree of certainty that those objects are directly related to our query vector. So what we're going to do is we're going to pull out the closest one. And we'll see that if we compare these two vectors, the query, why do airplanes fly vector, is very similar to the NASA article vector. And that, in a nutshell, is how semantic search operates. It's pretty straightforward, unlike when you look at it this far under the hood. If you keep digging deeper, you run into a lot of algorithms that are a lot more math than I understand. But for all intents and purposes, the way that a vector database operates and the way that it is able to pull out semantic meaning is really straightforward. Okay, so before we move into a little bit more info on how this integrates into RAG search, any questions about the basics of vectors and vector databases? If not, that's totally fine.
Yeah,
What
It
is-
just means
I
that.
have
What a quick
I have a
question.
question.
Okay, yes.
In regards to what you talked about earlier, would more dimensions help define relationships, such as a relationship between a monkey and a banana, or a rabbit and a carrot? So basically, would dimensions create an understanding of relationship?
That's a really great question. The short answer is yes. The longer answer is to a point. For most use cases that you see out in the wild, having higher dimensionality is just going to take up more space in your database, and it's going to end up costing more money, and it's probably not going to make your returns any more accurate. Again, once you hit like 1,500, dimensionality of about 1,500, most queries that you're going to run are not going to be succinct enough to be able to pull out the extra information that those extra dimensions will give you. Now, if you were to create a vector database where you have billions of parameters that are all incredibly similar, and you need to get in there with an extremely fine point and pick out from very similar vectors, the ones that are most similar to your query, you might benefit from going with higher dimensionality. But for the most part, it's just going to take up more space in your database, and you're going to have to pay more money for it. Okay. Any follow-ups, or I think somebody else maybe had a question?
Yeah, I guess this is Pranav. I can go next if you don't mind. So, does things like what we talk about parameters or weightages, does that play into this as well? And if it's the right time to talk about it, can you elaborate on a little bit how embeddings and then the training of the model with those weightages or parameters play into
Ooh,
the vector
great
data?
question. Yeah, great question. So awesome. I think we'll talk about that a little bit in a slide, or in a couple slides, but let's touch on that now. So we use these machine learning models called embedding models to create vectors. And not all embedding models are created equally. In fact, we have different embedding models out in the wild. There are thousands right now that are better at certain things than others. There's some that are old and just not like super great anymore, but we have very general embedding models, like OpenAI's embedding model, very general. It's been trained on the vastness of the internet. So you could throw just about anything in there and it's going to give you a vector that's probably going to work pretty well. We also have embedding models that are fine-tuned for specific domains, to your point, because of the training data that they've received. So for instance, Cohere has a really great model that's been trained on medical data. It's been trained on the entirety of PubMed, which is the published medical journal repo, as well as millions of patient charts. So that embedding model wouldn't do great for general RAG, for general queries. But if you are a physician or working in a hospital, something like that is extremely important. The same thing exists for law. The same thing, actually, Cohere is a great language model. If you are working in a business where you have a lot of different languages spoken and queries are going to be coming in from virtually everywhere on the planet, their model is really great because it's very good at handling multilingual queries. That answer?
Yes, thank you.
Yeah, you're welcome. Cool. Awesome. And thanks for hitting up the chat, dude. I appreciate that. Okay. Did I miss? Or is there another question?
Yeah, I had
Yeah,
a question, Scott.
it's about indexing. So when we
Oh,
use
indexing. Good.
proper indexing to, in a traditional databases that we use, how this applicable in vector database? Because it's a 3 dimension with the similar patterns. Let's say if you have a banana and also you have a banana, the same dimension with this, will this indexing cause the problem, right?
Good question. Yeah, so vector databases use a completely different form of indexing. Most modern vector databases use what's known as hierarchical small world graphs, HNSW indexing, where essentially you are able to index in a way that allows you to have different layers of information. Because the way that we measure the distance between, let's say, our query vector here and the vectors around it, you could use something like KNN and brute force it and measure the distance from your query vector to every single other vector in the database. Like you don't really even need an index for that because you can just do that every single time you make a query. But as you can imagine, it's really expensive and it's really slow. So instead, we create these layered indexes that have different number of vectors in each layer. And I'm giving a very quick synopsis of this. But essentially what this allows us to do is it allows us to come in at any entry point in the vector database and then make these big jumps until we get close to our vector that's closest to our query vector. And then we can start making tinier jumps to see which of these vectors in our database is the closest to our query vector. So
Okay.
the indexes operate a little bit differently. Did that answer your question, or did I just muddy the water with that?
Yeah, that sounds good actually. So yeah, but when you have that poor query, right? So how you rank it with this low available objects, which is like they are not in, it's kind of you're searching the needle in the hay, right? Something like
Mhm.
how this indexing can helpful on that area. So because
Yes.
you have to rank also, right?
So we can use re-ranker,
Okay.
but generally, unless you call for a re-rank, it's going to use this form of querying or looking through the index. So this is a very rough drawing of the hierarchical small world graph, and showing this, like, these are essentially layered proximity graphs so that you can get to your actual vectors that you want more quickly. So the way that this works without re-ranker is, let's say that we have our target vector here. Each one of these layers is going to have a different number of actual vectors in it, or the index is going to have less vectors in it the higher you go up. So instead of having one flat graph where you're having to jump from entry point to entry point to entry point to get to the closest vectors to your query vector, you can actually make bigger jumps so you don't have to travel through the entire index. I liken it to, if you were to try and get from your house to somewhere, like, let's say, a specific address in Paris, France. If you were to traverse the entire index from a random point, you're going to have to pass through every single point to get to where you're going, to find the point where you say, okay, these are the closest to my query vector. That would be like going house to house all the way until you got to the house you want to go to in France. When we introduce these layered proximity graphs, we're essentially creating different layers of the index. So these points in the top layer, which has the least number of vectors in the index, these are present in all subsequent layers. But what this allows us to do is, this is like getting on a plane in the United States and it'll say, like, flying to London. And then you get to London, you say, okay, still not that close. I'm going to take another plane to France. And you get to France, you're like, okay, I'm going to get a bus and take it to Paris. And you get to Paris and you're like, okay, I'm getting closer, but now I'm going to take a taxi to this neighborhood. And then you can, when you get to the neighborhood, you can start looking at individual houses and say, okay, this is the house I'm looking for. Maybe kind of a weird explanation, but what do you think? That answer your question?
That sounds good. That's opening eyes. So just really good. Yeah, keep going. Yes, you're doing awesome.
Awesome. Thanks. Appreciate that. Okay. Do I have another question?
I had one question, Scott. So I was
Yes.
asking on the chat also. So the numeric comparison, like the traditional database we use, right? That does comparison of if this number then greater than 6, pull all the records. In this case, it doesn't happen, right? So if I say, if I have
Ooh, good
IMDb or
question.
movie database and I have a movies rating like 9 and above or 8 and above, and if I want to, on my chatbot, I want to search the movies that are rating 9 and above, does this vector database going to work?
Ooh, good question. Yeah. So from what I understand, the question is, yeah, we have this vector database full of movies, and we want to know just the movies that score 9 or above and like IMDb or reviews or something like that, right? Or maybe Rotten Tomatoes.
Yeah.
Do numbers translate very well to vectors? They don't, right? Because there's really no semantic meaning in numbers, because the number 9 could be talking about how many birds are on a wire or how many dollars I have in my pocket. There's really no way to understand the context of a number. So this is the beauty of vector databases. They not only store the vector information, they also store the original object itself. So when you are working with text, you can semantically search for that vector. When you're working with numbers, you can actually search the numbers themselves like you would in a traditional database. And we'll talk about that a little bit in the workshop, but you essentially set filters. You can run filters and vector searches concurrently so that you can pull out the numeric values that would be really hard to catch with a vector. It's a really good question, by the way.
Thank you.
Okay. Any other questions before we move on? Great questions, by the way. This is fun. I really appreciate them.
So in this case, we are going to, it's kind of LLM models that we are searching, right? So there won't be numbers. So basically, I will be looking for a text-based search. So there's exact terms that will be searching is in semantic search, or the terms are sometimes they misspell, right? You know?
Yeah, because we're using semantic search, it's great with misspelling. In fact, we can play with that a little bit when we do some
How the
vector database
exact
queries.
match, if it's misspell, then how the dimensions will work. I mean, it's gonna search for that objects, right? If you misspell, the searching would be difficult also. It's gonna take some long time.
Not necessarily. No, it's really good with, and I'm not sure exactly what's happening under the hood with the embedding models themselves, but they've been trained to overlook a lot of spelling errors and kind of understand like what you mean, especially since our text is going to be tokenized anyway. So it's going to remove a lot of the filler words that we use in language that the model doesn't need to understand the context of the statement.
Okay.
Yeah, that's another great question. Yeah, it's like an LLM. You know, you can talk to Claude and misspell everything and run words together, or even have one sentence that's like one long word and it still somehow knows what you're talking about.
Yeah, absolutely. Yeah.
Yeah. Okay. Lost my chat. Where's that? There we go. Okay. Oh, was there one other question? Cool. All right.
Scott, just a question.
Yeah.
About the context, that's why it is very important to describe the context to find the relevant data. Is that the point here?
Yes, we want to use context. You're absolutely right. And we won't get into this, but when you build your data set that you go in, that you create your vectors from, the context can be very important. And I said, like, it doesn't matter, you can misspell things. But actually, you can misspell things. But the amount of text you put into each one of these vectors does matter. So for instance, let's say that we'll actually look at a database of books. Let's say that we want to create a vector space around some of our favorite books. We could take the entire book and turn it into a vector. But when we do a vector search, we're going to pull out an entire book. And most of the time, if we want information from a data source like a book, we want like a chapter at most, right? We probably want a paragraph or maybe a page. So like most things in data cleaning is pretty important. It's a really important first step. It's not as important in a vector database as it is in most data science applications where your data has to be, super clean in order to do any analysis. But it does take a little bit of thought when you are creating these vectors. What you would probably want to do with a book is you want to divide it up into chapters or pages and vectorize those. But another thing that you can do now is we have different Python scripts that you can run that will look for natural breakage in the data structure. So like in text structure, it'll look for different paragraphs or different page numbers. So you can chunk it up that way. But one of the things that I've been playing with lately, which is really cool, is I've been running the small version of ChatGPT locally on my computer. And I've like kind of taught it how to read text and chunk it semantically so that if it gets to the end of a page of a book and it sees that like the paragraph's cut off, or it reads that whatever the character was talking about or whatever the main point was still continues in the next page, it will identify that and not break it up. So it's going to, we can tell LLMs to actually chunk our data for us so that our vectors are not breaking up an idea or the context like midstream. Okay. What do you think? Hope that answered the question. Cool. Awesome. Okay. Yes, exactly. Chunking strategy does really help. I mean, you can't arbitrarily chunk it. I've done that in a few projects where I just am like, I want 500 characters with 200 character overlap, and it works fine. But if you want something really robust, it does help optimize your search. Okay, so let's talk about why vector databases matter in the big scheme of things. And if you haven't guessed already, we're going to be talking about RAG, retrieval augmented generation, because ultimately that's why we have vector search, is because we want to make search more effective. So one of the things that's we're really good at Weaviate is we work with just about every embedding model under the sun. So if you want to use Weaviate, it's totally free. You can run it locally. We're open source, so we won't charge you for it. If you want to run in the cloud, of course, we'll charge you for the space. But if you are running just general search on general data, we have general models for that. If you have something that's really specific, like I was saying, the medical embeddings, we have models for that too. We work natively with just about everything on Hugging Face. And the methodology behind setting up a vector space is actually pretty simple, because essentially you just take your data and you can send it to the Weaviate client, which we'll work with a little bit in our workshop when we're going through the actual notebooks. And with a single API call, it's going to not only ingest your data, but it will vectorize it with the ML model of your choice, drop those vectors in your database, and maintain the original objects as well, as I said previously. So if you have a search that is going to be more appropriate for vector search, you can do that. If you need to do some filtering, you can do that too. And one of the things that we kind of tout at Weaviate is we're just really easy to use. It's literally like 8 or 9 lines of code, and you can have a database set up, which again, we'll cover that in the notebooks. So this is essentially just an illustration of what we already talked about. We like to query our database, how do airplanes fly? Just like our data, it's going to go through the client, through the application, and it's going to vectorize it, drop it into the database, and it's going to return the object or objects that is closest to our query vector. And I forgot to say something when I was asked a second ago about pulling these from the database. What about the number of objects that it pulls, right? How do we know? When we're running a SQL query, it's pretty easy. That's really well defined, right? We can tell it how many we want to pull, or it just pulls all the data that we've written about in our SQL query. Weaviate works very similar. You can tell it how many objects you want to pull, or we have this nice feature called AutoCut, where it will intuitively understand how many it should pull based on their proximity to your query vector, which I'm going to show this picture really quick. So with AutoCut, which is a really nice feature, so you don't have to think about how many objects you want to return every single time you run a query, it's going to look at your query vector, and it's going to look at the relative distance between the closest objects, and it's going to say, okay, these are all pretty close. These ones are all far away. So these 4 that are really close, I'm going to pull these. But these other 4 that are relatively far away compared to these 4, we don't need. So it's a really great way, if you're running a RAG system, to intuit how many objects to return without you having to do that manually every single time you run a query. Okay, yeah, so that's it in a nutshell. So that's how the query side works. What do you guys say? You want to dig into some notebooks? Do some actual work? Instead of just listening to me gab at you all day?
Hey, Scott.
Ooh, or, yeah, I was just say, any other questions? Yeah, go for
Yeah,
it.
sorry, just can you go back to the slide? So there was a link to ML model, right? So your vector database already has data that's already been vectorized. For example, let's say we have an application and we have a data, right? So we should have already done all the embedding and captured into this Weaviate database, right? So when the query comes in, it will have its own embedding, and then it's just going to do a search. So why there is a link to model? I didn't understand that part.
Oh, because we're going to use the same model that we use to create our vector database
Oh,
to
for the query
vectorize our
part.
query. Yep, yep.
Got it.
Yeah,
Okay.
and that's a great point, actually. So all these embedding models out there are doing the same thing, right? They're turning your information into vectors. If you try to query with a different embedding model, you're probably not going to get a good answer. And it goes back to training, because these embedding models are all trained a little bit differently. So they're going to position objects in the database differently relative to each other. So when you're working with vector database, and Weaviate will make sure that you are using the same embedding model for queries as you did to make your vectors in the first place. Yeah, you just want to make sure you use the same one.
Thank you.
Yeah, good question. Okay, did I? Oops. Before I make you guys run these notebooks, it'd be nice if you had the right requirements files. Okay, so I'm going to spend a few minutes going through just the basic setup of our notebooks. And then we're going to do some breakout rooms for about 10 minutes, just so that anybody who wants to run this code live, Dude and I are going to split up so that we can make sure that those of you that want to run the notebook live with us can. Oh, I just saw another question. So it's the AutoCut capture feature. Just capture the vectors in this cluster. Those four embeddings in your example. Ooh, good question, Jeff. Yes. Yes. So it's going to, what it's actually going to do is it's going to look at the, we'll say probably 20 to 50 closest vectors. I'm not exactly sure the number, but it doesn't really matter. It's going to look at like X number of closest vectors. And let's say that we use cosine distance. So let's say we have a vector that's like 0.61 distance away. We have another one that's 0.62. We have another one that's 0.62. And then we have one that's 0.63. So those are our first four, 0.61, 0.62, 0.62, 0.63. And then the next one is 0.66. So it's going to see that those first four are within 0.01 distance of each other and 0.03 distance of the target, or yeah, of each other, and 0.63 to the target vector or to your query vector. And it's going to see a jump there because we went from 0.63 to 0.65. So that's a jump of 2 units or 0.02 units. 0.02 is not a lot in normal life, but when everything else is 0.01 to each other, which is closest to our query vector, that jump of 0.02 is meaningful. It's saying that, okay, there was a jump here, so I'm going to say that this vector after the jump is not important, and neither is anything else after it. So we're just going to keep those first four that are relatively the closest to our target vector.
And that's based on the cosine similarity?
Yep, exactly. Yes, I see that you put that in the chat. Yep, great.
Yep.
Yeah, and honestly, most embedding models these days are trained on cosine similarity. There's some old school ones, yeah, that were trained on like Manhattan distance or Euclidean, but to my knowledge, I don't see those out in the wild anymore.
Yeah. Attention's all you need.
Yeah, good one. I saw that there was an attention is all you need to out recently. I haven't read it yet though. It's like a sequel, I guess.
I said, oh,
Okay.
nice. Yeah. I was like Godfather 2 versus Godfather.
Yeah,
Better.
it's exactly. Okay. Great. Thank you so much, Lucas, for sharing the repo. I should have done that. And if you opened it before I just did that last push, you might refresh. Oh, and if you are running locally and you've already downloaded the repo, you might do a pull really quick because I added the requirements this morning. And actually, I think that's all I added this morning. So that would be the only thing you're missing if you did it really early this morning or last night. Okay. Setting up a vector database with Weaviate is actually really simple, and you can do it for free. If you haven't done this already, what you'll do is you will head to the Cloud Console. Oops. I want to open that in a new tab. There we go. And you will create an account. I already have one, so I'll just use mine. I remember my password.
Scott, we can run this locally though, right?
Yep, absolutely.
I mean, we can open it in Cursor and
You
go.
got it.
All right. Thanks.
Yep, good question. Yeah, so I'll talk about that here in a second. You will just create a cluster in the sandbox. You click create. Oh, we'll call it TSD agent. It takes about 3 or 4 minutes to set up. So I'm going to move to something else while we wait for that to set up. The reason that we are setting this up is because we want to collect our REST endpoint. This is how the address that we're going to reach our database at in the cloud from our client. And then here in a second, we'll create an admin role so we can get a key for it. But Jeff had a great point. Let's talk about how to run this. So you can download the repo and run it locally in Cursor or VS Code or your application of choice. You can also, if you don't have those things on your computer, you can create a code space in GitHub directly. So once you're in the repo, you need to be signed in to do this. So if you don't have a GitHub account, you'll have to create one. And you can create a code space on main. This takes a few minutes too. But it's a really easy way to be able to run code without having to worry about setting up like a virtual environment on your computer if you've never done that before. And we'll just be able to install the requirements that text here. Yeah, go ahead.
Where is the email and instructions to set this one up? And even I haven't done this, so probably, I mean, you sent an email or someone sent an email a couple days back, right? So
yeah, and it was just a link to this right here. The instructions are all here.
Scott, I just cloned that repo and start updating the environment variables. That's it?
Yep. That should be all you need to do. Oh, and then yeah, we'll run the what am I trying to say? Installing the requirements as well.
Scott, can you please repeat the code space part?
Yes, sorry, I got sidetracked. Okay, so we hit code here, and we hit new workspace on main. Did I already create that? Yes. And when you hit new workspace on main, it will bring up this very familiar looking, almost VS Code like interface. It looks like it takes a minute to set up. It looks like it's still sitting up down here. Beginning terminal running. Yep, there we go. Okay, so your cluster, if you're playing along at home, Your cluster should be set up. And again, I'm going to go through this very quickly now, and then we're going to do breakout rooms. So if you're not caught up with me, that's fine. We're going to do breakout rooms so we can get this set up for you guys. So you'll want your REST endpoint because this is going to be how we communicate with your database. And you're going to want to create a file called .env. And this is just your environmental variables that your notebook will be pulling from. And if you look in your instructions, it says here are your env variables.
Oh, we need to create that file, .env file on our VS.
Yep. Yep. Yeah, and it's easy. Just new file .env.
Ah, nice.
Or is it safe to copy the API keys, like the OpenAI keys in this code space?
Yes, this is only available to you. Good question. Oh yeah, and we will need an OpenAI key. I forgot about that. Good point. What do we call it? OpenAI. I will pop this in the chat.
So the Weaviate URL and key, we'll just, can you show me the sample file of that .env?
What was that?
Can you show me the .env? Oh, okay, that's what it is. Okay, fine.
Yep.
What is OpenAI? Oh, if you're connecting OpenAI API key. Okay.
Yeah, we're going to use this to run simple RAG to create a generative response to our query vectors.
I'll add my OpenAI API key in my personal.
Where is
And
Weaviate
you know
key?
what? You know what? I'm going to go ahead and I'm going to make a burner key here really quick, and I'll share it with you all. Come on. Where are we?
So Scott, if we're running this locally, do we need to have Weaviate APIs still?
Yes. Yep.
Yeah.
Yeah, unless you're going to Dockerize it, then you wouldn't. You just need your endpoint, your local endpoint. But yeah, I didn't include Docker in this repo. That is a fun
Okay.
way to do it, though. Okay.
I'll call the endpoint.
Oops. Okay.
Can you put some sample? It's supposed to be equal. After that, I have to put the JSON. Or can you put some sample that? Yeah, just remove.
Yep. Sorry about that. Thanks. Good catch. Good catch.
Okay, got it. Also, can you help me how I get the OpenAPI key?
I just dropped it in the chat.
But what about
And I'll leave that.
What about Weaviate key? Where is that?
Oh, yes, thank you. Okay, so yeah, our cluster is now set up. So we've got our REST endpoint right here. So we're going to put that for our REST endpoint. And then the admin key is we have to make. So API keys right here, just scroll down a little bit. We'll go create API key. And I'm just going to call admin and give it admin. And create. This goes away. As soon as you close this out, you're not going to be able to pull it back. So make sure you hit copy. And you drop it in. So Weaviate key.
So it doesn't have to be in the single quotes, right? The URL, the Weaviate key or open API key. Okay.
No, shouldn't have to, because we will do that in our when we load our .env.
Got it. Got it. Thank you.
Okay. So then once our .env is all set up, the last thing we'll need to do, and I hope this works, pip install -r environments txt.
Okay, text that command.
Yep. Yes. Yes. Thank you. Good thinking. Oh, and if you don't know how to get there, I will show you how to do that as well. So, gosh, how do you do it from here? Forgot how to open. Forgot how to open terminal from. It's been too long since I've used this. How do we open terminal? Let's ask.
And that pip3's not working.
There's a keyboard shortcut. Top left. There it is. Thank you. Thanks, guys. Terminal. New terminal. Yeah. That's how it's done.
Can you show the env file with the top two variables?
What's that? Oh, sorry. Yeah.
So those first two API keys, those are the keys from
From Weaviate.
Weaviate URL.
Yep. So it's going to be the Weaviate URL is going to be your REST endpoint.
Oh, okay.
Okay. Dude, what do you think? Should we hop into some breakout rooms to
Can you
mash
allow
it
me
away?
just another
Yes.
couple of minutes just to complete this .env and pip install part?
Yeah. We'll give it like 3 more minutes, and then we can hop into break rooms and we can address any issues with, if there's any issues with like requirements.txt or anything like that.
Yeah, I think
that's
the
totally
pip
fine.
install not working. Maybe I need to work with you. Why pip install not working? Actually, I don't understand it.
And yeah, if you're having any issues like that, you can pop in the chat the error you're getting, or you can wait 2 minutes and we'll address it in the breakout room.
What did you paste for the Weaviate keys?
Yes. So for the Weaviate key, you will go back to your cluster,
Yep.
scroll down, and then create API key.
Yeah, I have the API keys.
Great. Okay.
So that's what
So
I paste here. But what is the open API keys then?
Oh, that one I popped in the chat. So that one's one that I made that we can use for the workshop today.
Okay. So
I'll leave that active for the rest of the day so that it's available.
Okay.
So you guys don't have to go make one of your own.
Got it.
Just try not to rack up $1,000 worth of API calls because I
Scott,
can't afford it.
into the breakout room, like I just want to know my pip is not working. Even in pip3, I put it, but it's asked me to set up the Python environment. Do we need to set?
Oh yeah, if you're running locally, let me show you how to do that. Assuming you have Python installed. Yeah, I'll run through that really quick in the last minute. So the code is going to be Python 3 -m db.weaviate. Oops. And actually, I'm going to type that.
Path to the environment, right? Path to it.
So that sets up your event. And then to activate it, this will activate it. Oh yeah, thanks, Gary.
Yeah, can you put it in the chat as well, Scott? Thank you so much.
Yep, I'm dropping it in the chat as I go. And then,
Oh,
then you can do.
Or requirements. Yeah, text all 3 lines, yes, together. Thank you.
Oh yeah, all together. That's a good idea. Okay, let's do some breakout rooms.
Okay, perfect, Scott. I will be putting everyone in the breakout rooms. Okay.
Awesome. Perfect. Thank you so much.
Wait a minute, let me copy it.
Okay, 1 second.
The remaining people who are still here, you guys must have gotten your respective rooms, so please join it because there will be a quick demo there. Thank you.
Lee, please accept the invite. Okay, you have it.
Okay, perfect. I think
Everyone-
everyone's in the waiting room, right?
Yeah. So should we pause the recording or?
No. Keep it going. I think it should be
Okay.
I'm just worried if it will stop recording in the waiting room because I mean the breakout rooms. It should record those as well.
Breakout rooms में recording नहीं होती.
Oh, okay. So it's okay. Fine. Should be okay. Another thing.
We can talk on chat. It's being recorded.
Scott, you are muted.
Scott, you're muted, by the way.
Thanks. So it looks like everyone is back, right? I think we're all here. Or is it just
Couple
my
of
group?
people are still joining. They're still in the breakout rooms.
Okay, great. That's actually helpful. I've got an error in my notebook. I'm trying to troubleshoot on the fly here.
Okay.
Everyone is in the main room, Scott, now.
Awesome.
Yep, everyone's here.
All right. We almost got this worked out. So we might just have to do things a little bit differently. Okay.
So start from our background, we got that everybody is connected, like they're able to see the
Scott,
I'm sorry, I'm a bit confused, Scott. Are we doing everything in the GitHub dev, or do we need to also open up an own terminal and then copy the repo and do something there?
Oh, it's up to you. You can work through GitHub Codespace, or you could do it locally on your machine. And as someone else pointed out to me, we could also do it in Colab, Google Colab.
This were mostly in their personal collab, right? So if someone is using cloud instance, how would that work?
Sorry, we asked that again?
So there is a own personal console and a cloud instance, right? If we are directly using the cloud instance, how would this work?
In GitHub or
yeah,
in Weaviate?
In the GitHub and
GitHub?
working with the cloud, right?
Yeah.
Weaviate cloud.
Yeah.
So how would that connect?
Oh, it's going to connect through the client, through the Weaviate client, which we will instantiate here in a minute once we run through the workshop.
Thank you.
I'm having some issues with running some of the generative searches. It's weird. I just tested this last night. It's like something changed. Sorry, guys. I need one more second to troubleshoot this. Very strange. Okay, we may just have to skip some of the generative stuff. It's only like 2 cells, which is fine. So I'm not exactly sure what changed. Okay, well, I'll cross that bridge when we come to it.
Scott.
Yes.
My first setup was successful, but doesn't I need to keep going? I stop on connect to Weaviate. Is necessary to keep going?
Oh yeah. So we're going to go ahead and run through that right now. Okay. And maybe I'll do in code space. Well, no, I'll do it here in VS Code. Okay. Okay, so here we are. We set up our env, so we have all of our different keys. You don't need the cohere key. That's left from something else I was working on. We should have created our env and our requirements.txt. We should have installed all that. So we can go ahead and start with our first notebook. So we talked a lot about how a vector database works. We put vectors in, we can query it, and we can pull those vectors out so we can get some information. And we talked a little bit about RAG as well. So we're going to now run this notebook, which should allow us to do all of those things that we just talked about. Since this is part of the requirements, we don't need to do this, but if you're running it in Colab, you could install this and be able to use the client, the Weaviate client. But the first thing we're going to do is we are just going to connect to our env file so that we can make sure that we've got our keys in here. So when you run this cell, you should see the keys that are in your env. If not, then you'll need to set your env up with these keys if you haven't already. Okay, great. That's awesome. The breakout rooms worked. Thanks, Duda. I really appreciate your help with that. Okay, so in order to communicate with the cluster that we created, we are going to activate the client. And what the Weaviate client does is it essentially abstracts out a lot of the monotonous code that we would have to do in order to communicate with our cluster, add a collection, add data to that collection. The idea is that the Weaviate client makes it really simple to be able to add data, pull data, make queries, and all of that good stuff. Again, because it abstracts a lot of the code out. That's the stuff that's the minutia that's happening under the hood. That's when we want to set up a vector database query, we don't have to worry about all that hard coding ourselves. So we're passing in our environmental variables that we just pulled in here to our .env, and you should get client is ready equals true. That means that we're connected to the client, it's talking to our cluster, and we're good to go.
Scott, I hit into one error.
Yeah. Okay. Yep. Awesome. Thanks, Duda. Okay. Key 1220. Okay, so we'll start at the beginning here. So the Weaviate key, which should be in our .env, right? The Weaviate key is from our cluster. We scroll down and we hit create API key. And you put in a name and you choose admin and create, and that'll give you that key. Next question was the module not found error. Awesome, thanks, Duda. If you have more problems with modules not found, you'll probably have to run your pip-install or pip-install-r requirements.txt, which I will toss that back in the chat just in case. And I'll spell it right this time. Requirements. Pip-install-r. Yeah, that's right. Okay.
When you run the code, did you run one cell? Or how is that?
Oh, sorry about that. What was the question?
When you run this code, did you run one cell at a time, or how is that?
Yep. I'm just hitting play. Yep, running one at a time. Yep. So we just want to make sure that we're all connected to Weaviate. And if you run it again without closing, the client will yell at you and say, "Hey, you didn't close me. Stop trying to connect again." Okay. Awesome. Thanks, Duda. Great. Okay. Any other issues connecting to the client? It should say client ready, true.
It's saying type to choose a kernel source. Select kernel, it is asking.
Yeah, I'm also having the same problem.
Will somebody pop that in the chat? This is the fun part about coding live, right? Is that there's always something. And not find a version that satisfies requirements. GUI protocol. Okay, so a couple people have got this.
Even I got that, yeah.
Okay. Yeah. So
what is the kernel we have to
depends.
choose? No.
I think it might depend on which version of Python you're running. Let me see.
3 Python.
Should be an easy way to fix this.
Did anyone able to run it in CodeSpace?
Is it doing that? Is that okay? Let's try this.
No.
Okay, so I should have my requirements installed.
Invalid input error handwriting.
So
Okay, just select that.
yeah, the client ready is not coming actually.
That's interesting. It's not working for me in CodeSpace either, is it?
Why we're not able to get that kernel source?
There we go. Oh yeah, that's something that's CodeSpace is pretty slow. Okay. Then Weaviate URL is not defined. Interesting.
It is trying to install Python and Jupyter extensions.
All right, let's try this. I will troubleshoot CodeSpace with you guys. Okay. Okay, maybe it wants us to run a Vem fun on CodeSpace. So let's try that. We'll spend a little more time troubleshooting this. If we need to, I'll have to send some updates to the notebook later. Source. And okay, that'll do. Okay, so we'll see if this works. Should.
Was there any
Those
typo
of you.
Was there any typo that we need to update the code again in CodeSpace?
Maybe.
Okay.
Those of you that were getting could not find a version that satisfies the requirements. Actually, I'll wait till it finishes running because we may run into that. And if so, I can update the requirements with a different version. Yeah, this should, looks like it worked. So those of you that were getting the not find a version that satisfies requirements, did you create the ENV? Okay, you did. Interesting. Did you get to this part? Did it happen before or after?
So we
Before or after it got to this part?
create a
Yeah, what's
dot
that?
env, not dot venv. Can
Interesting. You know, we might just try, let's see.
so dot venv is a folder, right?
Which one?
Dot venv on the left.
Yes. Yeah. Yep. It's a virtual environment. Yeah. So it's basically a folder. I can
But
create these.
is anyone able to run? I'm still not able to run select the.
No, it's not working. Yeah, for some reason. It's always asking to choose the Python versions, libraries. It's never ending. It's one after the other. It is asking for.
Right. Let's see. I want to see if this works for me. And if it does or doesn't, what we might do is we might do, yep. Okay. Let's do this.
So Scott, like the generative search error that you were getting, I was able to solve it. I know why that error occurred. I can tell you that.
The generative search?
Yeah. So
Down
apparently,
here at the bottom?
client object that you had, right? You're using the OpenAI. When you click the OpenAI object, you're using the client attribute, which is Weaviate client that you created on the top.
Yeah, I'm
that-
using the client, right? Twice.
Yeah, twice. Yeah.
That's good to know.
Yeah.
Sheesh. Okay. Awesome. Thanks, Rajesh. That's really helpful because yeah, that was driving me crazy. Okay, so let's do this. Let's make a breakout room for anyone that needs help with getting the requirements going so that they can run the notebook. Is there a way that we can, I guess, how would we partition that? Or maybe we could do this. We can stay here and we can take like a little 10-minute break for those of you that are good to go and are able to run these first two cells. And those of you that are not, let's troubleshoot this.
Yeah, I was not able to run. I don't know. I cannot able to select that code base. So the kernel is still not able to select it.
So you're not even able to open code space?
The code space in the kernel, yeah. If you can help me, that'll be nice. Yeah.
Yeah. Okay. So you're here and you click on create code space. Oh, are you logged in? And by that, I mean, are you logged into GitHub?
Yep. But
yes,
this is my, oh, yeah, I logged into the GitHub, yes.
Okay. And you're in the repo here. And when you hit code and code space, what happens?
It says create score space. I don't have score space.
Okay, great. Yeah, go ahead and hit create code space and it should open in another window like this. Okay. And then
In the load data set, Scott, I'm getting this error rendering output item using this. But
what is it?
Error rendering output item using Jupyter IP or Weaviate renderer. Okay.
Oh yeah, I just yeah, try upgrading your IP widgets. Put that in the terminal. That should fix that. Okay. Paul, I think that you're not the only one having this issue. So here's what I'm gonna do. Let's do, how do I do this? Ooh, yes, thank you, Duda.
No.
Okay, so for those of you having issues with the requirements.txt or running these cells, let's try starting from scratch. So you should see here on the left-hand side of your terminal that you are in your venv. First off, does everybody see that?
Yes.
Yes.
Okay, great. Excellent. And then, so in that case, here's what we're gonna do. If the requirements.txt are not working for you, what to do, first we'll go deactivate. And then we're going to delete it. Oh, am I not sharing my screen? Okay, I am. I should be right. Can you guys see my screen?
Yes.
Yes,
Okay,
sure.
great. I want to make sure that I thought I had been sharing it this whole time. Okay. Okay. And then we're gonna go. We're gonna go remove our F, and we're going to tell it to get rid of our VNG. We're just gonna start over. Oops. Let's just keep that at the end. Should start from scratch. Try this all over again. And you should see that your .vem disappears from your tray up here. Also, could one of you guys that fixed my mistake of double using the client, could you send me what you did to fix that in the chat? That way we can address it when we get there and we can run the notebook. Joys of coding live. It's always something. Okay. So you should have your then removed. So now we're going to add it from scratch. And I'll pop this in the chat. This time it is spelled correctly. And then here, what that does is it creates our folder, our virtual environment where all our packages are going to be stored. And then we will activate it. And then we should
One thing that is interesting is to in the top right, that where you see Python 3.12.1, you can try to select the environment that you just created, just to make sure that the VS Code is using the same one. On the top right.
Oh yeah. Yep.
Yes.
Yes.
Yeah.
Thank you. Good call, Duda. So yeah.
Yes, this one. Yeah.
That's actually a really good idea. So up here in the top right of your notebook, term source is not recognized. Source. Interesting. I've never seen that one.
Of course. Are you running these on the terminal, right? So you can't. Oh.
Interesting. Oh, okay. Okay. Are you running this locally or are you running this in CodeSpace?
Oh, yeah.
Okay.
It's
All right.
on Windows, probably.
Yep. Yep. How do you do that? Windows. Ooh, just try this then. Yeah, I don't think you need the source for Windows. Try that.
After resource source, we need to again install again the requirements.txt.
Oh, yes, thank you. Yep, sorry, I got sidetracked. And yeah, let me know if that taking the source out of that was able to activate your environment. Awesome, thanks, Sudha. Okay, so yeah, if you just installed your requirements.txt, it should work. And if not, what I think we should do is we'll keep working through the material just so we can show it. And then, yes, good call. If you can't get it to code, if you can't code with this live right now, you'll have access to these notebooks and I will share my information. So I'd be happy to help you after the, whatever this is, after the workshop. Okay. So now, after the requirements.txt is all gone through its thing, we'll look at Python, we'll select another kernel, Python environments, just to make sure, as Duda said, we're using the right one. We should see our event here. So again, one more time, click on this, select another kernel, Python environments, because we're running Python.
I'm sorry,
Make sure that we see
are
our
you
event.
sharing? I'm not seeing anything. What are you?
I can see.
No, we
That's
can able
interesting.
to see. We can able to see, right?
I'm seeing the Connect Weaviate screen. Which one are you referring to?
Next, this one right here. Oh yeah, so I'm clicking up here on the top right
Oh, okay.
of the notebook and the bend. Yeah, just to make sure that you have the right kernel selected. So you can click here and click select another kernel and then choose
Okay.
Python environments just to make sure the stem is the one it's connected to.
Okay.
And then just for fun, give it a restart. That way we're sure that we're using the right kernel. And then after you've gone through all the requirements, you should be able to run this and it should connect. Okay, awesome. Pushpak, yes, let's talk about this notebook. So in a nutshell, the purpose of this notebook is to run through making some vector database queries. So the first thing that we're going to do is we are going to connect to the client, and then we're going to create a collection in our cluster, in our database, put some data in there, and we're going to run some queries. Okay. And again, could one of you guys if you got the, awesome, thanks, Bernard. If you were able to solve my issue of double assigning the client variable, would you mind popping that in the chat? So when we get to it, we can just paste that in.
So, oh, there you go. You got it. Ranga? No. So, Scott, I was going to put it in there. I was just going to actually copy and paste what Cursor said it did to fix it.
Great,
Will
that's
that
perfect.
work?
Yeah, and then we'll cross that bridge when we get to it. Let's see. Opening here, sure. Not type. Okay,
Oh.
so what that's saying is that your env file is empty. Ranga. So you're going to want to make sure that you got your keys in here.
Does the VNV file gets saved automatically?
Yes, it should.
Because sometimes it's not reading the file, it's giving me error. Though I have everything in the .vnv file.
Interesting.
If you don't want to use the file, you can just copy the data into
that's a
the
good idea.
Python.
Yeah, that's a really good idea. Yeah, Duda, would you mind helping Ranga with that if you can?
Sure. Can we create a break room for that?
Ooh, that's a good idea.
Yes, Scott, I'm still, and the environment is usually there. Maybe will help me. Yeah.
Awesome. That's great. Okay. Yeah, that's like, that's, yep. Awesome. Thanks. Can't believe it. Okay. So we've connected to our Weaviate client. Again, essentially the client is the way that we are going to be talking to our database in the cloud. So this out of the way. The first cell we're going to load is, we're essentially going to load this data set from Hugging Face. So we hit play here, and all it's doing is it's going to be creating a connection to this database in Hugging Face. Because what we're going to do next is we're actually going to make a collection in the cloud, and we're going to stream the data from Hugging Face into that collection. And the reason we're doing it that way is because this data set in Hugging Face, it has all of our objects, which is essentially a bunch of contracts with the date that the contract was made. These are our properties. Properties is another way of saying columns in vector databases. So we've got the date that it was made, the contract type, the author, the length, an ID that to return text of that contract. So yeah, right here, all we're doing is we're pulling this data set from Hugging Face, looking at a little sample of it. And now we're going to create a collection in our cluster to send this data to. So
I'm
play
getting
here.
Here, Scott. Can you hear me? Yeah.
What's up?
So it's taking a lot of time for me. For example, create a collection.
Are you in?
For
If you're
contract.
in, yeah, if you're in CodeSpace, it might take a minute. Sometimes CodeSpace works really well, and sometimes it's kind of
It
slow.
is extremely slow. It's not. It looks like it's running for infinite time. It's just running. Nothing is happening.
Yeah, you might try just giving it a refresh and then starting over. Sometimes that helps with CodeSpace. Sometimes.
So Scott, this data is already been it's already been embedded from Hugging Face. That's what it is, right? So it already has a embedding being done on that data, right?
Yes, yes, it comes with the vectors. And yeah, so how do you tell it comes from Hugging Face? So we're loading from data sets, and oh my gosh, how do I set this up? I think that data sets is their tool that you use to pull from them. But yeah, I should probably put up here, other than just Hugging Face, I'll put a link so you can see where this is coming from. Great question. Okay. So now what we've done is we created a collection. And remember, I told you that we want to use the same embedding model to query that we use to make the vectors. This data set tells us that the embedding model was Snowflake, version 2.0. So when we create the collection, we're going to give it a name, a little description so we know what's in it. This will also help our agents later. And then we need to configure the vectorizer, so the embedding model. And that's what we're doing here. We're telling it we use the model Snowflake to make all these embeddings. And the source properties is really important. If we were to put all of this information into Weaviate, remember when we send this information to Weaviate, it's going to vectorize it. It's going to turn it into vectors. By default, Weaviate will vectorize any text property that it sees. So we have a few different text properties here. We have authors, we have contract type, and we have the contract text. We're going to have a lot of the same author for these contracts. We're also going to have a lot of the same contract type. So semantically, that information isn't really that important to put into a vector, because we can filter for that. We don't need to have that semantically stored on information. So our source properties for this would be just the contract text. So if we were to use this vector, if we were to put more contracts in later, it's going to know that the text is all we want to create the vectors from, because we don't really need vectors from the other stuff. Oh, and this little line here, if the collection exists, deletes it. It's fine for notebooks, but not a great thing to have in production, right? Because you don't want to delete your collection every time you add data to it.
Scott,
yeah,
I have one question. So when we say that we got vectorized, we got the vectors back when we downloaded the data set, when we used that. And now here we are passing the data set to Weaviate and we are telling it which property to create vectors for. Could we not just like, what is the difference between these two vectors? And could we use the same vectors here?
Oh, yeah, good question. So we technically, since we're adding our own vectors, we don't have to tell it the source properties because we already have the vectors with it.
Right.
If in the future we were to add more contracts to this data set, if we don't give it source properties, it's going to vectorize all these text fields. So contract type, contract text, which is fine. It's not a tech, but when it comes to vectors and semantic search, these two properties are very repetitive. So
So we essentially have used the pre-built, pre-provided vectors that we are getting from Hugging Face. Is that correct?
Oh, we are actually. Yeah, we are using them. We're just telling it the vectorizer. So first we can query. And if we want to add more vectors in the future, we can. And we're telling it the source properties so that if we were to add more in the future, it would only be vectorizing what the important information.
But wouldn't that make the data murky a little bit of the vectors? Because the previous one, the half of that, or say majority of those would be, I'm assuming that those vectors are done on all the information, a vector is created for all the information. And then for the newer ones, we are saying only the source properties.
So this data set is only, the vectors have only been made from the contract text.
Okay.
So it will follow suit. But even if
so
it weren't true, even if, yeah, we did just default it and let it vectorize all the text, it would make a little difference, but probably not enough for us to get like a different response to our queries, honestly.
Okay. So even by default, we are just using the vectors that we're getting from Hugging Face is only for contract text as well. Is that
for this particular data set? Yep, you got it.
Okay.
Yeah, and honestly, you make a good point. It probably wouldn't move the needle that much, but just to be like really clean and professional, proper, yeah, that's why I put the source properties in here, but it would be fine without it.
Okay.
Really good question.
Yeah, I have a question. So the collection,
yeah,
collection is more like tables in a regular database, is that right? So so when you say collection, and so there is no, in vector database, there is no tables and rows, right? Columns and rows.
No, not technically, but if you want to relate the two together, you could think of the properties as the different columns.
Properties as different columns. Collections would be tables or rows?
Yep.
Tables.
Good job. Yep.
So how would you, I mean, in a regular database, you may name the columns as columns, I mean, after things like contract, like batch, size, and all that, conditions, leak. Here, if you are scanning this, how would this put the right values? I mean, so for this to work really well, the contract underscore type should be a unique name. Is that right? I mean, that is more like a column.
Yeah. If you were
If there is a
to
misspelling or something, so let's say, I mean, after a month, you scan another document where the contract type is not called out. I mean, so it's slightly different format. So how would it make sure it puts the right values?
good question.
Like this?
When you add your first object, if you don't define a schema, it's going to create a schema for you. And it will use these as your columns. If you try to put in data later on that doesn't share this schema, it's going to say, hey, wait a minute. I was expecting this schema and you gave me this. So you need to fix it.
Yeah, this is because of auto schema. So by default, it's going to have auto schema, right? You throw data in, and Weaviate's going to create it for you. But let's say that you go into production, and you in production we suggest to turn off the auto schema. So let's say that you have a mistype in contract type, then Weaviate's going to say like, oh, this we doesn't have this one. But for starters, the auto schema is on, so you don't need to worry about the properties.
Yep, exactly. Yeah, and if you're inserting in a batch like we are here, and it sees the first one and it's fine, it sees the second one, it's fine, it sees the third one, there's a typo, it's going to stop and say, hey, this doesn't match the schema, so fix it. Yeah. So it does a good job of, I mean, yeah, in production, you would definitely not want to use auto schema so that you don't put your first one in with a misspelling and the next 1,000 fail because there's no schema for them. But yeah, it does a good job of making sure that you're not putting in data incorrectly, and it's not going to arbitrarily create columns for you. Okay, great questions. Next, we're going to load the data into Weaviate. So we're going to essentially stream from data sets on Hugging Face to our financial contract table / collection in our cluster.
Is it necessary to load data set again? Because we already have it, correct?
Oh, did I already do this?
I mean, in the previous help, right?
Oh yeah. Oh my gosh.
I mean, I'm just confirming that we don't have to reload.
Yeah, you wouldn't have to load it again. Yeah, we've already done that. Good catch. That's what I get for working on things late at night. We had a product launch today, which I'm really excited about for our query agent. And I built a lot of the material around that. So I kind of had agents on the brain, but it was a lot of work and I stayed up too late the last few nights trying to get all this stuff done. Okay. So yeah, this takes a little bit longer in CodeSpace. If you're running this on VS Code or Cursor or even Google Colab, you'll probably notice that it's a lot faster. And isn't it creating a JSON schema? Contract. Yeah, basically. Good call. Yeah, so here we are passing the schema because it is, we're not passing it in and like vectorizing it. It's, a pre-configured data set. Very good catch. Okay, this is taking really a long time.
Hey, Scott.
Yes.
On the prior cell, we create a collection, right? So that's just creating a scheme, like kind of a schema, right? The one cell number 19 in the prior one, yeah. Create a collection of contracts. So So this one we are not referring to any data set. This is just kind of setting up a schema into the Weaviate database, right? And then you are loading it next because. Right?
So it's just creating the table, and we could create the schema here if we wanted to, but we don't necessarily have to.
Okay. No, my point was like the prior cell was just creating a collection and telling that, hey, I need this type of collection, and I want this type of model, and I want this type of vectorization on this column. That's what basically we are doing in that cell, right?
Yep. Yeah, good job.
Okay,
this is taking a little long. All right, so I'm going to switch over to VS Code here. Same exact notebook, just it should run a little bit faster. Okay. All right, already created collection. Okay, expect. Interesting. Yeah, so I just got the same thing. Okay, I think that's fine. All right. So now we're just going to do some basic contract exploration. Essentially, what we're doing is we have these objects now in our collection, in our cluster. So we're just going to fetch a few and see what it looks like. And as you can see, it looks essentially like it did when we checked the objects before from the data set from Hugging Face. So our objects are there. and they are in their original form. So we put the objects in and they keep their form, but they now have vectors associated with them. So we can pull these objects more easily using semantic search, which we're going to try now. And first thing we're going to do, run this little helper function. It's just going to make our output look a bit cleaner. And what we're doing here is that step that we talked about earlier, where we are going to take our query and we're going to send it to the database. And again, the client's going to send that to the database, and it's going to use our embedding model, that Snowflake model, to turn our query into an embedding. And then we're going to pull out the 3 closest objects to what we end up with this as a vector embedding. And for fun, we're going to return the metadata. So we're going to look at the cosine distance. So when we send that query, we get 3 objects back. And we were asking about employment contracts, the job role, salaries, employee benefits. And we get 3 employment contracts, which makes sense. We could read through them. We can see that they probably talk about the stuff that we asked for. And we have the cosine distance here. And these are going to be listed in ascending order. So the closest one is going to be first. And the furthest one is going to be last. And this is actually a really great example. If we were to use AutoCut here, which normally I would do some playing like that, but since we're on kind of a time crunch, I'm just going to power through. If we were to use AutoCut, we would see that we would probably just get these first. We would just get these first 2. Because we've got 0.504606, 0.5040606. And this one jumps to 0.514. So it's a pretty big jump from these 2 are virtually identical.
So
this is just 0.01 off.
Why do you call that as metadata? I mean, is that how it's called?
Yeah.
Because I heard in another review that metadata is used to pre-filter, right? So I mean, when you chunk a huge document like or something, and
good question.
Yeah, when you chunk a huge book, let's say Harry Potter book, I mean that will have several pages, paragraphs, so it's going to be huge. So metadata is going to help you further pre-filter, right? So, but here the cosine distance that is the output, right? So that's the result. So is metadata, is that the right term, or how do you think about
That's
it?
a good question. And I had a hard time with this as well. When we're chunking and we're creating that, what we would call metadata around those chunks, like what page number it came from, what article it came from, the author it was. In our database, we call those properties. And the metadata is going to be more the data that is even more meta than the properties, if you will. I've done a great job of explaining it. But yeah, I struggled with the same thing when I first started working with this. Because I thought, metadata would be what we call properties. And yeah. So yeah, good question. I'm not sure of the etymology of that.
Scott, one question.
Yes.
So it makes sense that we use the same embedding model to actually train.
Oh, I think I lost you. Are you still there?
Wait, sorry. Yeah, I was just saying, like, it makes sense that we have the same embedding model for the training on the data set that we are getting, and also for the query part. But once we're using a vector database and we are getting vectors back, do we need to have a compatible generative transformer as well to kind of, or does it not make any sense? Does it not affect anything? Because the thing is, like, would it know like what those embeddings actually affect what is generated when it comes to the text?
Do you mean generative model, like if we're setting up a RAG system, or what do you mean?
Yeah, so in this case, I say you're getting the vector database is going to give you certain embeddings back, all right? Like the closest based on the cosine distance. cosine product is going to give you the certain values back. But when you are, so that is okay if you're surfacing just the result. But if you want to actually get, I'm just assuming if you want to actually have a text output in an agent or in an assistant, would that matter what generated model are we using on that side to transform that?
Good question. Good question. Yeah, no, and it doesn't actually, because the vector database is responsible for pulling the context, which would be these data points, and it's just going to pass it all to the large language model.
What would it pass? Would it pass the embeddings, correct, or would it pass the actual results?
Yep, it's going to pass the objects.
Okay, all right, that makes sense.
Yep. Yeah, good question. Good question. Okay. So you guys already touched on this, which is awesome. We can also pull these vector embeddings with filters as well. And the way this works is really cool. It's a bit over my head, but you would think that you could filter and then pull vectors, or you could pull vectors and then pull filters, but actually these two things happen simultaneously, and it's super effective. So here I said, let's say that we want to find contracts from an author that we actually trust, like somebody that we know that writes better contracts than, we'll say, Jane Doe or John Doe, or I don't know. We can actually introduce filters by importing our little filter tool. And the filters probably look a little bit familiar if you've worked with SQL databases or relational databases before. They're very, very similar to SQL queries. In fact, they even work with regex, which if you've worked with regex, you know it is kind of awful. I've worked with it a lot and I have to relearn it every single time I learn it. But this works really well with regex. You can use wildcards, you can use things like that, same terminology. And you can then use those properties, which again, I, at least one other person, previously thought of as metadata. But what you're actually doing is you're able to filter through those properties, especially, as we said before, those that aren't vectorized, like the IMDb score of over 9 of a movie.
So when we say it happens simultaneously, is it possible that we are actually filtering simultaneously and the result would be the overlapping values of whatever the results are, correct?
Yeah, exactly. Yeah, isn't that cool? It took me a long time to wrap my head around this and ask like 1,000 questions, but yeah, you nailed it. That's exactly what's happening. So we're getting the best of both worlds, and yeah, we're finding the intersection of the two. And I'm showing you filtering and not other things like VM25 and hybrid search for a reason, because we're going to build, I'm going to give you guys the punchline. We're actually going to build on this when we start building agents in the next workbook. Because, as you can probably imagine, filtering is great. But if you have a RAG system, you probably don't want to be writing filters by hand every single time. And you could put in a bunch of fields for different filters that you want to run. But that's a lot of extra work for both the builder and for the user. And we're going to see that it doesn't have to be that way. There's actually a really cool way around it. Okay. So this is where, right, we need to do like OpenAI client. And then I think that's what we need to do to fix this. Yes. Oh, thank you guys for figuring that out. Oh, I can't believe I did that. Okay. So as we were just talking about, sometimes we want an LLM to be able to generate an actual useful response for us from the objects that we return. Because like vector search is cool. It's really great to be able to pull information from your database that looks very similar to what you're asking for. A great example of this is, most companies have gigabytes of unstructured data that they've been storing for a rainy day. I mean, if you think back to the early days of Hadoop, we were able to finally collect all of this unstructured data. And the idea was, okay, we're eventually going to come up with a way that we can parse it. but without a ton of work on the front end to put this unstructured data into a form that makes sense to a more relational type or adjacent database, it's really, really hard to be able to pull that data. Being able to pull that data is great. I can search for these contracts and I can read them myself, which, you know, saves a lot of time in search. But what if you have a specific question that you want answered about this breadth of data that you have, with hundreds, if not thousands of gigabytes of unstructured data? Instead of having to just read the top hits, we can actually have an LLM do that for us, which is the heart of RAG, right? Is to be able to generate responses that make sense to humans based on text that makes sense to humans. And that's essentially what we're doing here.
Yeah, I still get an error when I run the last part, the query optimization. Is there something that I had to fix in the code, or maybe it's the key that is not API key that is expired? I don't know.
It's a good question. In fact, this kind of got mixed up on me. So you're trying to run this cell?
Yes.
Okay.
I get an error. I think it's error code 429. When I check that error, it says you've exceeded your current quarter.
Ooh. Let me try and run this again. Yeah, we may max out my key. Oh no, that's weird. I'm not sure.
Yeah, so yours, yeah, same key that I'm using from you. So
weird. Yeah, you could. I mean, you could set your own up really quickly, or I don't think I didn't give due to any shareables. I can try and make one if we have a little bit of a lull.
Okay.
Okay. So actually, what I want to do here is a little bit different. Yeah. Okay. I got my thing mixed up a little bit here. So what I was actually trying to show here, I now realize, is we can leverage LLMs to help us with our vector search. So the RAG thing is actually down here. We're going to talk a little bit about RAG. What I was trying to show here is we can actually use LLMs to help us maximize the efficiency of our vector search. And by that, I mean, sometimes humans don't have the best methods of communicating. And this is not that far-fetched of a query, right? I need contracts that have good info on what I need to be looking for when signing a new contract for a job. It's a nice run-on sentence. There's a lot of filler here that doesn't necessarily need to be there. And we see a lot of people in everyday life that kind of beat around the bush. It takes them a long time to get to the point. Vector databases are really great with semantics, but you don't need to tell them everything that you're thinking. You don't even need to use complete sentences. If you're searching for contracts with info about jobs and high pay, you could literally just search contracts, employment, pay, or high pay. You don't need to have all the rest of the filler words, because in machine learning, they cut out a lot of that anyway. When they tokenize, they remove a lot of those fillers. So you can actually use...
Sorry, yeah. Quick question on that. If we do only use keywords, does that take some of the context away? So would the attention side of things would take a hit?
Good question. Generally, no. I mean, you could make the argument that maybe there are some important keywords that get taken out, but generally, those will probably be taken out anyway under the hood of the large language model, or even of the embedding model itself. Because, you know, filler words aren't really that important to context, and they're certainly not important when it comes to like the transformer model architecture.
Yeah,
that is a good question. I can see where that could possibly happen, but I would say like probably 99% of the time, probably not.
Yeah, and for me, the only thing that I was thinking is like, because for the semantic search, right, the whole semantic side of things does depend on grammar. So if you're taking some of the grammar stuff out of it, I don't know, it's interesting. I was just curious.
Yeah, that's a really good point. Yeah, and I think if you were vectorizing individual words or individual sentences, yeah, I think you're right. You might run into a problem with that. Generally speaking, though, we tend to vectorize larger chunks of information where there's a little bit more contextual data there. But yeah, you make an excellent point. Okay, so I'm building towards something else with this as well. You can actually take your queries and make them better by asking an LM to, hey, make this better for me. And you'll end up with, this is OpenAI. If you were to use Claude for this, you'd get a little different response. It would be a little bit more truncated, but OpenAI is a lot more robustly trained on like being really verbose. So we don't just get keywords here, but we also get a sentence that's much more structured and is more in line with what the LLM assumes that we're looking for. Okay, so this was just another example of using near text, but we don't need to talk about that anymore. So, this is my OpenAI client. Now we can look a little bit more about, oh, no, that's not.
That's the real
that is
client.
yeah, that is my real client. Thanks. Okay. So now we can start using an LLM to help us answer these questions as well. So we're not using it to create a new query, but we can use it to actually answer some questions. So again, this is basically, this is RAG. Like we just built RAG here. And we took a lot of steps to get here because we have been talking about, you know, how vector databases work and near text and queries and filtering and all that. But literally, you could set up a RAG system from start to finish, creating a collection, loading data, and then hitting it with a generative model and like 20 lines of code. It's super easy with the client because, again, it abstracts a lot of the stuff out. I did for South by Southwest here in Austin this year, I did a talk for LangChain, and I essentially showed like the difference between using LangChain to create a RAG system and then using the Weaviate query agent, which we'll talk about in a minute. And it took like 150 lines of code to use LangChain. It took me like 20 to do it with the query agent. And they were like, come on, dude. But I was like, hey, I used LangChain to do all the chunking and all the data processing. They're like, okay, fine. That's cool. Yeah, we like that. Okay. And what I've shown here is we can get the generative responses in two different flavors. There's what we call single prompt, where we pass in our vector objects one at a time. And we say, okay, based on this object, answer these questions for me. What are the risks or potential issues that I need to worry about? And it will go through these objects one at a time and answer that question based on that one piece of context. Hence the word single prompt. Each object gets a prompt. Alternatively, that's not generally what we want. When we're searching for something, we usually want several pieces of information to inform one unified response, where we can use a groups task, where the group task says, okay, instead of giving me one response per object, take all of these objects as your data source, as your context, and then give me one unified response. Okay, and that's really vector databases in a nutshell, start to finish. You now know more about vectors and vector databases and RAG than probably 99.9% of the people on Earth, because it's very esoteric, but yeah, it's not super complicated, especially when you write your code correctly. Okay. So now,
Scott, there is a problem.
Yes.
Yep. I just put it in the chat. I know that we have already fixed that error.
Trace back, we get classifier. Oh, yes. Sorry about all the scrolling, guys. I'm just gonna get up here. Where is it? Okay, so here's how you fixed it. You just put OpenAI underscore before client right here and right here. So I'll pop this into the chat.
But I didn't get this error here. I think I got it. in the financial code, generative search ask questions about contracts. So I got the error right there.
So absolute question. Oh, yeah.
Yeah, here only. Yeah, just can you scroll up?
This one.
Scroll up. No, just before that. No, just go up. Generative search.
Sorry.
Yeah, here. Generative search.
Okay. Did you change the other cell previously with the OpenAI client?
No, there was no error for me in the prior cell.
Yeah, so you need to, if the code is as it was, this client is duly assigned to our Weaviate client and to our OpenAI client. So you'll need to go up and fix this cell and then go back and rerun that other one.
Okay. Can you paste this part for this optimization?
Yep, just popped it in the chat for you.
Hey, Scott.
Okay.
Scott, can you go down a minute on that query, the RAG query, please? That one. So contract risk liability issue problems, is that the user query, and then the prompt is what I'm trying to understand the use case. So the prompt is very deterministic, right? The prompt is very deterministic. So it's like this is a deterministic use case where, like I'm trying to understand how the user query is mapped to a very deterministic prompt here.
Yeah, so the objects have these properties. They have contract type, they have author, they have date, all that stuff. So what we're doing is we're saying, instead of using the entire object, I want you to use the contract type and the contract text to answer this question. We don't have to do that. If it passes the entire object, like it's fine. It's probably going to understand. This is just like, a more clean way to do it. Is that what you're asking?
Yeah. Is this the prompt like,
oh yeah.
Yes. Is the prompt, where is the prompt coming? Is the LLM, no, the prompt is deterministic. I've already specified the prompt, and in how the query maps to the prompt is the LLM magic, right? Is that what you're trying to say?
So this is going to be sent, this prompt is going to be sent to the LLM 3 times.
I see.
Because each object is going to have a different contract type and contract text. So we see this here, we're going to have 3 different responses. So here's the 3 risks for the first contract that was returned. Here's 3 risks for the second. And then, this is truncated, but here's 3 for the third.
I see. Got it. Okay. Thank you.
Ooh, Alberto, great question. Chunking. His question is, this example is based on a nicely structured data set. Yeah, it's not bad. Can you describe how to approach similar use case with free-form documents? So it really depends. If you're working with like PDFs, if you're working with just like a wall of text, if you're working with like a medical document or a science journal article, if you're working from like a text document versus HTML, there are a bunch of different tricks you can use on the chunking side. And chunking itself is like a whole 5-hour workshop because there are a lot of tricks of the trade. But essentially, it depends on your source data. And it also depends on the individual structure that it has. And if there is no structure, you can arbitrarily chunk it up in pieces, like 500 character pieces that overlap by 200 characters. So if one does bleed into the next, you hopefully capture it. You can divide it up in paragraphs and pages. Yeah, there are a bunch of different flavors. I love chunking. I could talk about chunking all day, but we're running out of time. Okay, let's talk about agents. This is gonna be really short because I really want us to play with some agents. We're gonna build an agent here in a second. Agents aren't that novel. They've been around for a while, actually. I think what's changed in the last 1.5 years, almost 2 years, is that we're finding more use cases for them, and LLMs are becoming more intelligent and they're becoming smaller, which is the exact opposite that we thought would happen. So you can do a lot more with agents than we ever thought we could. And an agent is really, really simple. It's essentially just an LLM with access to tools. And instructions around how to use those tools. Like in a nutshell, that's all agent is. You have an LLM that you say, okay, if you experience this, do this. Here's how you do it. Jeez, my Siri just went off and it scared me so bad. Sorry about this. It should be alone in my office. That really scared me. Yeah, so that's essentially it. Agents are simply LLMs with tool access and very specific instructions on how to use those tools. Generally, they should have very specific instructions. So, you know, we live in, like, we're currently in the age of agentification. These agents are actually a lot more naive than we give them credit for. It's when you start chaining them together where like the power really comes from. And I'm not going to talk a lot about agents. I'm going to talk about the three main flavors they come in, but I think it'll be more effective. I mean, unlike vector databases where there's a lot of nuance, agents are pretty straightforward. So I think we'll learn more from just like getting our hands in and building some. But the main flavor of agent is tool pattern use. This is the one that most people are and have been building with, where you essentially have a flow where you start with some type of action initiated by the user. The LLM is going to look at the different tools that it has access to. It's going to use those tools to get you a result. It's going to take those results and craft a response, and it's going to send it to you. Super easy. The tools come in all different forms. We're going to be using a just generic LLM tool that we're going to have the LLM make. And we're going to also use one that we're going to clearly define, but have it make itself as well, which is kind of cool. But, you know, there are a lot of other tools you can get it. So we will be using vector search with our agent today. But like there have been a lot of really great agent workshops lately where people have used agents to like draft emails in response to emails, or draft or actually create calendar events based on emails that you receive in your inbox. Or if somebody like wants to have a meeting with you, like your agent will read it, make sure that the person is legit, and then actually schedule time on your calendar. Yeah, there's been some really cool stuff that's come out lately. Some agents, even within the tool space, can also have different reflection patterns. So this is a little bit more advanced than just the like taking a tool and beating you to death with it. You can actually incorporate into your agent flow a little bit of reflection. We're not going to be doing this today. I don't think I built that in any way, but essentially you ask it to execute a task or use a tool, it generates a response, and then it either sends that response to a different LLM or it'll send it back to itself. It'll have a think and it'll either say, okay, yeah, no, this is right. Or it'll say, nah, we should try again. This is one of my favorite aspects of agents right now, because like 3 months ago, Cognitive AI, who built Devin, and Anthropic published papers on the exact same day about agents that said two totally different things. Because the creators of Devin said, you know, when you're building agentic systems, don't put a bunch of agents in there. Just use one agent, give it the tasks you want it to do, and let it handle it. Because it reduces the complexity of your system. It significantly reduces token burn when you keep feeding the same LLM its own information. And it can get things done relatively accurately with a lot less overhead. Anthropic, same day, said the exact opposite. They said, you should be building your agentic systems with a bunch of unique individual small models. Because what it does is it actually increases token burn, which will get you better results in the end. And also, there have been a lot of really great papers that have come out talking about using small LLMs, like really small for very specific tasks, in order to improve the response time and to significantly cut down on costs. So we're talking, you know, like LLMs that you can run from your computer running in tandem, or maybe in an orchestration that can perform really complex tasks. Sorry, LLM, small large language model. I know it's conflicting, right? But yeah, so smaller versions of the large language models that have very specific tasks that they can perform in unison or in orchestration, because you get, if you're running them locally, you get a lot more bang for your buck because you don't have to pay for compute costs, and you generally get more think time. The last one is the planning pattern. And this one is probably the one you're most familiar with if you're using something like Claude Code, because Claude Code is very, I mean, everything Anthropic does is super transparent, but you can actually watch this happen with Claude Code because it will make a plan. It will show you its tasks and it will go through this process of completing them. And when it does, it comes back and it checks them off the list. In fact, this is one of the coolest things, in my opinion, that Anthropic has done, is this idea of giving LLMs like a cheat sheet, like a notepad, where they can keep track of their tasks and they can keep checking in on themselves to make sure that they're actually completing what they need to do and that they're staying on track and they're not, you know, going off on a tangent and doing something really weird. Okay, that's all I have about agents. So like I said, I think it'll be way more fun for us to build one. Okay.
Second one, can we run even if the first one never completes?
Yes. Yeah. So this one should run without any problems. And I put this in here so if you want to do this later on your own time, if your notebook isn't working, yeah, you can do that. You won't have to type in everything that I'm showing you guys. So this should be installed already, requirements.txt. So the first thing we want to do is we want to create a workshop that, an agent that does something fun. So we're going to use Agentic for this, which is a really great way to be able to build agents because it's super easy to chain them together. And we're just going to call the agent. We're going to use GPT-4o Mini. And all we're going to do is give it some instructions. So we'll say, I mean, everybody says this, so we'll just go with this convention. You are a helpful assistant that likes to answer questions. And you can tell it to do whatever you want. This is just kind of what I was thinking about earlier because it's easy. You enjoy talking so much that you always leave us wanting more. Say that, wanting more. So you always ask a follow question. Okay, now assuming this notebook is working, should just be able to run it. And it's not. I wonder, it should be it. Try this. Huh, interesting. Okay. Well, I have a typo in here somewhere. Let's see. Oh, it needs to be a capital I. I forgot about that. It's a weird pedantic idiosyncrasy. Oh, still doesn't like it. What is going on?
It worked for me with a small I.
And where to the small? It's weird. I have a typo somewhere. I'm not seeing. Okay. Oh, I gave it a capital I. Okay. Coding live, so fun. Especially when you can't spell. Okay. So now we'll ask it, yeah, what is Data Science Dojo? And look, It knows us. And then it asks us a follow-up question. So let's try to give it an answer and see what happens. It doesn't know what we're talking about. Well, you guys probably guessed why. Because this LLMs are stateless, right? Our vector database is stateful. Like you put something in there, it stays forever. But LLMs are stateless. In fact, that's the main difference between the vector databases that work within the transformer model architecture and the the vector databases that we use today. Is that because LLMs they don't have memory, or rather LLMs don't have memory because of the way that their vector database works, is it's stateless. They dump in the terms that they're using to try and predict the next term in a sequence, and then it gets kicked out. Whereas your vector database, that will stay there until you delete it. Okay, so let's try this again. We're going to go and run our first question. Yes.
Can you please go back to the second instruction because I'm getting typo again. Okay.
One of these guys?
Here. Let me check.
And is it this one or the second one?
Okay.
It's probably the first one.
Yeah, that
I can also
that
copy and paste
instruction.
that. Okay. So we'll go ahead and ask it the same question again. It says, have you ever considered taking a data science course or workshop yourself? Yes, I would like to do that sometime. Let's see if it remembers. So that's a pretty nebulous statement. If we did this right, whereas we introduce message history, and we're going to give it all of our messages, it should find that the most recent message in that thread and use that preferentially to answer or to use the context for the question that we just asked. And if that most recent question was not about what it seems like we're referring to, it would look a little bit deeper, which again, is essentially how memory and LLMs works, right? Okay, so there we go. We just built our first agent. We gave it some instructions and it followed those instructions when it felt like it was appropriate. And this time, in this case, we told it it was basically always appropriate, right? Because we're saying anytime you ask a question, ask a follow-up question. So super, super simple agent.
So that
Let's try something a little more.
Sorry, Scott, quick question. So that result dot all messages, it's went back and took all the results from the previous results.
Yep.
So the previous ones they didn't overwrite because
I'm sorry.
The previous result, right? We have the previous. You asked question twice and you stored it in the same result variable.
Yep. Yeah. So it's gonna store it all. So yeah, it stored it twice in that history, and also the slightly different responses. Yeah.
Okay. Thanks.
Okay. So let's build a little bit more complex agent. We're talking about vector databases today. Let's build a vector database agent. So first thing we're going to do is reconnect to Weaviate. So we've already seen all this. Just connecting to our client. Articles config. And contract config. There we go. Okay. So just making sure that we're looking at the right collection, which we got that. Financial contract. We got all our collection information here. And we've already ran this. We'll go and run it again. So first thing we're going to do is we're just going to create an agent like before. But this time, let's call it search agent. So we're going to say search agent.
It threw an error on the check collection.
What's that?
It threw an error, yeah, in this cell. Client
Yeah,
collection.
I accidentally called this articles.config. If you're getting an error, you just need to change it to contracts.config. Unless you're getting something else.
Oh.
It's just stuck in the beginning. Okay. I'm just going to go ahead and copy and paste this. Okay. Sorry, we good to go on that one? Okay. So just like before, we're going to set up our model. Set that as OpenAI GPT-40-mini because it's free. And set up our instructions again. This time I'll not capitalize it. And let's, so one of the things that we covered before was using an LLM to help you write a better query. So that's what we're doing here. We're going to give instructions. You optimize queries for contact search in vector databases. And then run search and return results. So basically, we're telling it you're an LM that's really good at optimizing queries for contract search and vector databases. Then you're going to.
Scott?
What's that?
Yeah, can you paste this part? This search agentic.
One more time.
Can you paste this part, the part that you added, right? Just now with the model and this.
Oh, copy and paste it?
Yeah.
Is that what you're asking for? Okay.
Yep.
Yes, good call. And then if you guys want, it's very similar, if not the same thing, in the completed workbooks up here. But I'll just pop that in the chat.
Yeah, Scott, just one follow-up. So in this case, the only thing that we're doing is we just have different instructions. Otherwise, the model is same. So the agent could be same, correct? It's just the initial system prompt that's different.
Yep. Yeah, so we're giving it different instructions because we want it to perform a different task. And then we're going to give it some tools here with this async function. If I did this right. So that part looks good. So we're saying basically we're going to wait, and then we're going to make this user query. We're going to optimize this user query. And then we want to, after we've optimized the query, this is the first step, we want to tell it to actually query the database. And this is pretty simple because we've done this already. We did this a bunch in the previous notebook. That's what I mean by this is actually pretty easy, because when we pass it tools, we're literally just passing it things that we do as humans in the code already. So we're just passing in the optimized query that we just asked it for. Optimized query equals the result output of its optimizing step. And then we'll set limit equal to 3 again, just so we get the top 3. And then we're going to print the results. So yeah, it's super simple. We give it some instructions. We define what we want it to do first. We want it to pass what it's this optimization step. We're going to pass this into our response variable, which again, we did this like 5 or 6 times in the last notebook. where all we're doing is we're going to query near text, and we're going to use that optimized query instead of a query that we made ourselves. And hopefully it works. I'll just pass it something really simple, because this isn't a great what I do. Oh, what did I do? GPT-40. Sheesh. It knew what I meant. I need an agent that works with me with my code. I know it knows what I mean. Okay, that looks like it's working. But it's definitely taking a long time. Yeah, I need to remember. We should, next time I'll probably use Google Colab instead of CodeSpace. It's just a little bit too slow. Any more to-dos? No. Okay, great. Oh, what did we do? Deadline exceeded. Okay, yeah, it took too long. So I'm going to cheat. Okay, which one do we do? This one. Yep. Oops. Guess it helps if I set up the database connection. Sorry for all the scrolling, everyone. Okay, one more time. There we go. Yay, it worked. So yeah, we can see essentially what it did was it did exactly what we asked it to. We asked it to optimize our query, send that query, and bring us back some vector objects, which it did pretty well. Yeah, building agents isn't that bad. Got one more to show you, and this one we're not going to live code because it's a little bit more complex. But if you don't have a tool that you have explicitly defined, LLMs are really great at taking examples and running with them, right? In fact, one of the more recent kind of breakthroughs, if you will, in prompt engineering has been if you give an LLM examples of what you want it to do and the output you want it in, it does a lot better job of keeping that and giving you what you want. So here, we talked earlier about filtering and how it's very like manual because you have to tell it exactly what properties you want to filter on and what terms you want it to filter on. But what if we have a bunch of collections and we don't want to go through and figure out which properties we want to filter on for all of them? Or what if we just don't feel like building the different filter fields into our search? Well, let's have an agent do it for us. So here, what we've done is grabbed a collection and list the properties and pass that to our agent and say, here's what you're going to do. You're going to analyze the properties of this collection, and then you're going to build some filters for us. Here are some examples. If you don't need filters, then don't worry about it. We then give it the filtering tool so that it can pass those filters in, and we ask it for the response. So let's see what happens. So there we go. It's created custom filters for us based on natural language. We just told it a little bit about how you would create filters, and then we gave it the ability to create filters and to call on our collection. So, I mean, this code isn't like insignificant. I mean, it's not super significant, but it's not insignificant because it's, takes a little bit of logic. But this is so much less work than creating custom filters for every single query that it's not even funny, or even building the fields to be able to allow users to create their own custom filters in their in their chat interface. Okay. Any questions about those fun little DIY agents? Yeah, basically, Jeff. Yeah, you stop prompting, right?
Scott, which part of that, I know you're setting the agent, right? Search agent equal to agent, and you're defining the model and model. So is that the one that's going to calling the LLM, or is it Weaviate behind the scene calling the LLM?
Oh, it's this one calling the LLM. Oh, this is the LLM for the agent itself. So we're not doing any generative. We're just pulling objects.
Okay.
If we were to then call a generative model to take these objects and give us text back, we could do that one of two ways. We could use Weaviate to do that like we showed in the previous notebook, or we could ask the agent to do it. We could say, then take these objects and give me a response.
Okay.
That's a really good question. Yeah, you can do it either way, which I'm glad you said that. I'm gonna alter this notebook so that's exactly what we do. So instead of just printing the objects, we actually get some cool information back. That's a really good idea.
Okay.
Scott, question on Weaviate in general. So right now, we create the collection and then we're obviously querying that. So it's kind of acting like data storage, a database. That's exactly what it is. But is there like is there a flavor that Weaviate offers which can act more of a in-session cache? And I don't want to save that for offline or for further ones, but just for this particular cache, like in the memory.
Yeah, so we do offer caching as a feature for sure.
Yeah.
And it's not that difficult to use. In fact, I have a workshop that I do on that as well, on caching.
Okay.
And it's about as short as this agent one because it's super easy to turn on. And it's pretty effective. It saves a lot of time. That's a good question. Okay. Well, guys, we have about 10 minutes left. So I'm just going to briefly introduce what we released today, actually. And that is the query agent. And like, I knew that there was no way we'd get to this part, but I have a notebook in there for you. So we already built our own agent that can query our database, which was kind of fun and not that difficult. And that's essentially kind of the foundation for the Weaviate query agents. It is an agent that is basically, I've described it as rag in a box, and it's really fun to play with and it's free to play with. So if you are interested, you can actually go into the Cloud Console and click on agents. And you can, use the query agent for free if you feel like playing with some fun agentic stuff. But essentially, the agent does everything that we just talked about and a lot more. It can create custom filters or dynamic filters like we just did. You can give it access to every single collection in your cluster that will choose dynamically which collections to use in order to answer the questions. So really great question earlier was, what if you have like a bunch of different like unstructured texts? You chunk it, you put it in, you can divide these up into different collections. Like for instance, let's say that you have a collection of internal documents that you don't want every employee to have access to, only certain people. You can set it up so only certain people have access. And then you can search over every single collection you have with one call using the query agent. It also does the automatic prompt, or it does the prompt optimization as one of the initial steps. What else does it do? I thought I had a list here, but this notebook, if you'd like to run it, it shows you all the functionality of what like a true database, vector database query agent can do. Because it can do RAG right out of the box, filtering. It can run aggregations, which I think is one of my favorite things because vector databases and LLMs aren't great at math. But if you ask the agent a math problem or anything that has to do with math or counting or calculating like contracts, for instance, like calculate the most the greatest distance between two contracts, it will actually run aggregations for you and show you what those aggregations are. Ooh, good question. I'll get to that in a second. Yeah, and I think one of the best things about RAG is its ability to tell you I don't know. Right? There was a paper released recently that showed that the reason that LLMs have a hard time saying no is because during their training, they were more strongly rewarded for giving an answer versus no answer. So they've kind of learned to make things up because they were rewarded more strongly for making things up than they were just saying nothing. And not only will the query agents tell you it doesn't know, but if you ask it a question and it has conflicting information or it's missing information, that will be one of its outputs. So it'll actually tell you if there's missing information or if there's conflicting information, which, Namrata, that's a very great question because yeah, you're probably gonna, if you have a bunch of collections, you're probably gonna have conflicting information. But this notebook is in the, what is this? The repo here, if you guys ever wanna run it. It's pretty fun. You can also get in there and, like I said, it's free to use, so you can alter the prompts, you can try new things, just get in there and play with it. That's what I've been doing the last couple weeks. Okay, so yeah, I think that's all I have for you guys. I'm glad we've managed to make it through everything. We got to talk about vector databases and how to search them, got to talk about agents, we got to build some agents, and yeah, I got to briefly introduce the query agent. Which conflict? Yeah, you guys are welcome. Ooh,
yeah, Scott. So I was just wondering, the point that Namrata mentioned about missing or contradictory data. I wonder if there's we could add some tools in there or some kind of like a resolution technique, or like, hey, if you know the way we have in GitHub, right? If you merge conflict, like okay, go with the new one or the other one.
Absolutely. In fact, that's a really great question because you could build that into like the agents that we built, or you could also use like the Weaviate query agent as one of the agents in your agentic framework. So you could tell another agent, look at this output, and if you see anything like this, use this tool or follow this step.
Right. Yeah. Cool. Thanks.
Yeah, you're welcome. And then, yeah, to add to what Duda said about the limit on the number of calls on Weaviate, yeah, no limit on the number of calls to the vector database. If you're using the query agents, right now, I think there's a limit on the number you can make per month, but we're working up a pricing plan. So if you do end up using it in production, there's a way around the limit. Yeah, so thank you guys so much. I had a lot of fun. Like, I love how back and forth this was. It didn't feel like me just like talking at you guys. I really love all the participation. That was really cool. This last 3 hours went by really fast. Reach out to me. I am usually around. Let me throw my email in here too.
Hi, Scott.
Yeah.
Yeah, just make sure like you will send a record video and relative slides, right? Later.
Yes, so I believe Data Science Dojo will be handling that.
Cool, thank you.
So I don't know if I'll have the. Oh yeah, Duda too. Yeah, Duda's awesome. He knows way more than I do. He's a really good guy to know too. And he lives in a really cool place in Brazil. So he's really interesting.
Hey, Scott,
awesome.
The cluster that we created on the GCP, how long will it be accessible?
2 weeks.
So okay, no way to extend that one?
Yes, so the sandbox clusters should be good for 14 days. Am I right on that, Duda? Like
That's
90...
right. So you can create a sandbox. It's going to run for 14 days, and you can also extend that a little bit.
Mm-hmm. Okay.
Scott.
Yes.
Sorry for asking that again, but I'm still stuck on the beginning of the second notebook. I copied what you pasted there, but the problem is still happening.
Can you try clicking in the complete notebook and trying to run that?
Okay, I tried that, but I will try again.
Yeah, try it and send me the error, because it could be a dependency issue.
Okay, let me see. I will send you the whole error.
Yeah, you guys are so welcome. Thank you all for coming. And I think we're gonna get kicked out of here in 2 minutes. So if we get cut off, did you save my email? Screenshot it?
But you can
Ooh,
send your
good
email
question.
in chat, by the way. You can do that.
Perfect. Awesome. Thanks. That's great. The OpenAI key, I will leave that valid through today, maybe a little bit into tomorrow. But you can make one for free. They give you $10 free if you make one at OpenAI, which is, it doesn't sound like very much, but that's a lot. Okay, what do we got here?
One more point, like, so we have a lot of chat discussion here. So after we finish the meeting, are they still there or just like they all gone?
I think they go away. I think you can export it somehow, but I'm pretty sure it goes away.
Scott, this error is the same. I tried to run the complete one, about the
Doing the same
second
thing.
class. Yeah, same thing.
Yeah, let me see here. Deprecated quargs. That's weird. And are you in CodeSpace?
No, I'm running locally.
Mac or PC? Mac or Windows?
Okay, Windows.
Okay. Oh, okay.
But I'm using WSL prompt.
Yes. So it's telling me, I just asked Claude.
Does it have
And
more stack trace on this, or that's just that message that is saying?
There are more, but it reached the limit of this chat.
Oh, probably the most important part is on the bottom.
Oh,
yeah.
okay. I will try that. I will try to copy this.
I'm thinking it's an OpenAI key error. It's acting like if it's on Windows, you may need to pass that key differently. I would recommend cutting and pasting that into Claude. It'll tell you exactly what to do. Or yeah, copying and pasting the very bottom of it if you have access to it.
Oh, okay, understand. Here's it.
That's a good call, Tita.
Let me see, because it reached the limit again. Okay, now I can send it.
Yeah.
Yeah, it can't see the OpenAI key. How is that being passed in a Windows computer? Can you try?
Yeah, so you can probably try to hard code in the code. So it's probably trying
good
to
idea.
get the environment variable. It's not being able to, and then you're probably passing an empty API key to OpenAI, and OpenAI say like, no.
Ah, okay. I will try that.
Yeah.
All right, let me. I think I can send you a little snippet really quick before this closes.
The environment is wrong. It's not open on AI underline API underline key. It's different. Okay.
That'll do
Thanks
it.
for the help.
That'll do it.
Are you from Brazil, Diogo, by any chance?
Yes, I am.
Oh, okay.
You too?
Yes, me too. Yeah, I could get from the accent.
Okay.
Okay. So you probably want us to leave. We can go.
Okay. Thank you very much, Scott. It was a pleasure.
Yeah, thank you guys. Thank you guys so much. I really appreciate it. Enjoy the rest
Thank
of the
you, Scott,
conference.
for such a wonderful workshop. Thank you so much, everyone, for joining and being so interactive. This was such an amazing workshop. We'll be sending all the resources as well as Scott's slides and everything, so don't worry about that at all. Thank you so much for your time. I've also left a feedback form, so please don't forget to leave us a feedback for the workshop. And that's it. Thank you, Scott. Thank you, Duda. Thanks, everyone.
Thanks, Scott.
Bye bye.
You.
Thanks. Bye bye, guys.
Oh, I have a question. When we can get this recording? Sorry, I already explained. I mean,
You'll be getting a recording by like maybe start of next week or so. But soon we actually have workshops lined up tomorrow and day after tomorrow as well. So right after that, next week, early next week. Okay.
Thank you.
Thank you, everyone.